I'm going to focus on what are the critical nuggets you're going to learn in part 2. We're going to focus on sensors, neural network models, and talk about different kinds of metrics. What I want to do now is actually take each one of these and talk about what we're going to pick up. Once we get into the meat of the course, there's going to be a lot of information coming at you. Trust me, it's going to be coming at a good pace. You're going to pick up a lot of good knowledge, and what I want to try and make sure you understand is how things are laid out for you from now on. TinyML is all about sensors, and I showed you earlier many different types of sensors. So why did I pick these 3 particular types of sensors to teach you about TinyML? Acoustic sensors, image sensors, and motion sensors. Let me ask you a question. What is different about each of these sensors? What does an acoustic sensor hear? And what does it generate as an output? An acoustic sensor is basically picking up sounds. For instance, if we use microphones, that's an audio signal. Then how do you take an audio signal and try and pre-process it in a way that you can feed it into a machine learning model? Can you just directly feed that time series audio signal, or you have to do something else? You'll be quite surprised at how we actually do this. Then an image sensor like a camera is an example of a perception sensor. We are going to be using a traditional image sensor that generates pictures. If it's a picture, you might be using a traditional convolutional based neural network. But you might say, well, I've already dealt with that, with pictures in part 1, or I've dealt with pictures in the past. Oh, well, you're still going to learn something new. The reason is because we're going to be looking at how to actually reduce the amount of time that's actually needed in processing this input that's coming in. The third one is the accelerometer. Where do you find them? Well, you find them in industrial applications such as motors, aircraft turbines, or drilling machines, where motion sensors generate time series data. We'll talk about this a bit more, but the key thing is that each of these sensors are quite different, and that's what's really exciting about them. The industry largely bins these sensors into 3 V's: V for vision, vibration, and voice. The first being vision, with cameras, lidars, radars, sensors for perception, how we see the world, whether it's with looking at it in terms of temperature, in terms of depth, and color vision. The second one being vibration, dealing with data for movement or motion, using different kinds of sensors such as accelerometers, gyroscopes, load cells. And the third one is for voice, such as microphones. This effectively allows us to teach you many interesting things, because we are looking at very different dimensions of how sensors are actually used in the TinyML application space. Then there's an aspect of the network itself. What is it that our network has to learn from these different kinds of sensors? Because the input is actually quite different, and you might have to do different things with the network. And that's what that's what is going to be the interesting thing. For acoustic sensors, you're going to do something different. For image sensors, you're going to do something different. For the accelerometer kind of data, you're going to do something different. In fact, in the last one, it's actually going to be quite interesting. You'll be surprised about the kind of network you're going to look at. So you should ask yourself, are all neural networks the same in order to deal with sensors? That's the question that we're going to try and answer in this course. Then, of course, what metric that we are going to go after to evaluate how good our machine learning model is actually going to be. So is there a single metric that matches all different sensor inputs, or how the network processes them and generates the output? Or is there a unique sort of metric for every kind of sensor input? Should we consider just a single metric when we are evaluating a particular sensor? Is accuracy all we care about? Or are we actually going to consider multiple metrics? So we're going to learn quite a bit about that. And hopefully in doing that, you'll pick up the nuances that it's not always as simple as it might seem on the surface. And that's what's going to make you different when you say that, hey, I'm actually a TinyML engineer. When we are talking about metric assessment, we're going to talk about metric assessment in the context of resource constraints that we are facing today, right? And that's in the context of the embedded device. So we'll be training models so that we are actually fitting into the rough constraints that we're going to face in terms of time, in terms of energy, in terms of memory, and so on. Again, we're going to look at the end-to-end flow where accuracy trades off with latency, memory footprint, power consumption. All of that is extremely important. At the end of the day, my goal is really quite simple. I want to help you understand how to apply TinyML, how to actually make it useful and you develop something useful. What does that mean? That means that you have to understand the intersections between the application space that you're focusing on, what the machine learning models need to look like, and how you build that machine learning model in the context of the embedded system. I touched on this in part 1, but a quick recap. One of the key things when we are looking at applications and we are trying to use ML is we want to understand what are some of the interesting applications out there where machine learning is actually the right tool. Please take away one thing from this course is that machine learning is not like a hammer that you can just knock everything out with. It's sometimes good, it's sometimes not good for those applications. I'm going to try and teach you that later on when you deal with motion sensors as to when machine learning is good and what type of machine learning is actually good for a particular type of application. Now, once you decide that machine learning is the right solution for the particular application problem you're trying to solve, then how do you build and squeeze that machine learning model with its unique constraints, of the embedded hardware? So we'll look at training-based methods to compress models. Then we'll look at different types of network structures that can fit into resource-constrained devices. And then we'll also be looking at what are the trade-offs that you're going to make in order to try and squeeze your networks down into the embedded hardware. We'll be looking at 3 different types of applications in great depth, and you'll see what the fit is and what the lack of the fit is also. Now, that's what part 2 is going to be all about. It's all about understanding these applications from the perspective of the sensors. And one thing that I want you to understand is that we're not actually going to physically deploy anything yet onto the TinyML hardware. The core nugget of this part is to take the machine learning fundamentals that we all know and then apply them in the application space and try and understand what are the trade-offs we make and how we optimize the models so that they fit into this. This is one of the critical stages. You don't always want to just dump directly into the hardware. You iterate at this stage quite a bit before you actually push things into the hardware, which will happen in part 3. And that's when you'll actually be getting a kit. And with that said, you'll soon be deploying your models that you trained in this course onto hardware. So stay tuned for that.